Hello everyone, and we're back from one more Block Magic workshop. Right now with us, we have Alejandro from Avalanche, Colombia. And thank you so much for taking the time to be here with us. As you know, Avalanche is one of our hackathon sponsors. They have $25,000 in prizes. So do check this workshop, take all the notes you need, and yeah, let's have some fun. Alejandro will take you through Avalanche's network. So yeah, with that, Alejandro, I'll pass it to you.
Okay. My name is Alejandro. I am Avalanche Technical Ambassador, and I am working with some different things about Avalanche. I started as ambassador last year. Yeah, I will be your teacher in this presentation. Okay, let's start. I start. Okay, let's start. Yeah, Avalanche, a network of networks. And this presentation is focusing in understanding why Avalanche is considered a network of networks. First, if we want to know why Avalanche is a network of networks, we want to know at the beginning what is Avalanche. What is it? Avalanche is an open source platform for launching decentralized application and enterprise blockchain deployments in one interoperable, highly scalable ecosystem. No, if we want to compare Avalanche with other blockchain, maybe we can think, okay, other blockchain, other option for this hackathon could be use Ethereum. Ethereum is focused in decentralization and security, and it has a branch or thing that it is not good. That is the scalable. In that case, we will show you how we can use Avalanche in order to get this scalable. No, Avalanche is the fastest smart contract platform in the blockchain industry as measured by time to finality. Maybe you can think, okay, what is time to finality and why is important the time to finality? In that case, I would like to show you an analogy. This analogy is focused in the time to finality and throughput. Both are different performance metrics in order to measure the Avalanche ecosystem and how we can get or improve the things for developers. In that example, we can see or we can imagine about Avalanche as a blockchain or the blockchain in general as a highway. For example, I am in my house and I would like to move me from my house to the supermarket or from my house to the beach. And in that case, I would like to use a highway, or I have to use a highway because I don't know how to teletransport myself to the beach or to the supermarket. I have to move me physically using any way. In that case, this is the blockchain is the highway. I have to use the blockchain in order to send myself to the supermarket or the beach. In that example, for example, I can be the transaction. The transaction is myself trying to move to the beach or the supermarket. For the reason, this is my house at the beginning, and this is the place, the supermarket or the beach. I have to take this car in order to send me from this point to this point. The short-term finality give me the possibility to send message to the right, to another position, another place in a short period of time. With Avalanche, we can make sure that the transaction, in that case myself, moving me through my house to the other place, the beach or the supermarket, can be explain me a little period of time. With Avalanche, we can get it. We can send transactions in a short period of time. If you want to send, for example, money, you can make sure that the transaction is okay in a short period of time. The second thing that we can analyze in this image is the throughput. The throughput is the capacity that you can have in this highway. If you have, for example, a highway with 3 lines or a highway with 5 lines or with 7 lines, if you have more lines, you have more throughput and you can get a little facility to send transaction, to send message. And in the example of people try to move from their house to the other place that could be, for example, the supermarket, boat, or anyone that can or do you like to move to this position can use this way. Why? Because it has a high throughput. In that case, we can merge and we can get a higher throughput. This is an example of the blockchain performance metric. In that case, we are measured by the time to finality. The time to finality in Avalanche Consensus can spend less than 1 second. It could be 0.5 seconds. In Ethereum, it normally spends 15 minutes, and in Bitcoin, you have to spend 60 minutes. Additionally, to have a short period of time to finality, we have a high throughput compared with other blockchains. Now, how we can get a throughput or a biggest throughput? The short time to finality, we can get it with the Avalanche Consensus. The Avalanche Consensus is named Snowman. Snowman is a consensus in what we can use in a statistically methodology to get the short time to finality. And the throughput, we can get the throughput because we can merge different subnets. You can imagine, for example, I am in my house and I would like to go to the beach. I have a neighbor that would like to go to the supermarket. In that specifically case, I can use the subnet one in order to go from my house to the other place. The subnet one gives me the possibility to move me through different places. And the subnet one can be, for example, a subnet focus in video games, subnet focus in a specific thing that have to do a lot of transactions to send information. The subnet 2 could be a specific subnet focus in a specific thing to send, for example, it could be an institutional blockchain. Subnet 3 could be the C chain. Those are examples, and we can merge the different throughput in order to have different lines. If, for example, in my city, I can take different paths in order to go to the destination. If I want to move me to other place of the city, I can choose between two different ways. In that case, I can go for the same place or a different place using different subnets because are different highways. And every highway can be focused in give me in move me to a different place or the same place. If I merge the throughput of different subnets, I can get a massive combined throughput of subnets, and every subnet can have the same short time to finality. And I can take advantage of the short time to finality and merging different subnets in order to have a massive combined throughput of subnets. No, what we can get if we are using this ecosystem, because with this ecosystem, I can get short time to finality and massive throughput. But what other things I can get if I are using this ecosystem, the Avalanche primary network? If I am using the Avalanche primary network, we can find or we can get the fastest time to finality, as we see in this presentation, in this slide. We can have a secure system because we can be sure. I think that the fastest time to finality is very related with the secure because we can be sure, we can make sure that the transaction doesn't have the possibility to change with the pass of the time. For the reason, if I complete a transaction, I can make sure that the transaction is okay. If I have the ID of the transaction, I can give the security to the client, to the user, that the transaction doesn't have the possibility to change. For the reason we can get a secure in a short period of time. With this order of ideas, if we have different subnets focusing different problems, solving different problems, yeah, we can have an scalable system because we can think about, okay, I have to solve a problem specifically focused in create NFT, interact different NFTs. In this with this idea with this mission in our mind, I have to create a system in blockchain that give me the possibility to send a lot of transaction on NFT because I have a video game and a lot of players have to have different NFTs and they have to transact a lot of time. For example, those players that they play about the video games or the shot video games, you can send some things or different things, different skins or any way that you want to send. And for the reason you have to use a lot of transaction. In a normal blockchain, it can spend a lot of gas and you have to spend a lot of money trying to move those assets between the network. In that case, we can create different subnets and we can focus in different things in order to send in a specific subnet focus using our project. We can have an independent subnet focusing in our project and we can be the most scalable that we need. Next, the energy and efficient lightweight. We have a specifically system in what after less than 1 second we have the transaction completely. For the reason we can we can have completely transactions after a short period of time. For the reason add information to the blockchain, it doesn't have a lot of energy. We have a more lightweight system in order to send transactions. For the reason we can pay less gas than other blockchain for saying the same process. The same process. Right now, we have more than 1,000 live dApps with many more in the pipeline. There are a lot of projects that are right now focused and are using this primary network ecosystem. Next, other thing that we can see when we are looking information about Avalanche ecosystem is that we have three different chains. Maybe we can think, oh, okay, I have to think about chain, next chain, chain, and a lot of chains. But it's simple. Let me explain you how you can identify everything. Exchange. Exchange is focused in the creation and management and transaction of assets. If we are creating or we were creating a specifically subnet, the subnet have to be located in a specific place and it has to has different assets, the native asset token. In that case, the exchange is focused in creation and management those assets that are unique for every blockchain. Other blockchain is P-chain. P-chain is focused in management of validators. Everything that you create a specifically subnet, this subnet has different validators, and every validator that is deployed are using are interacting with this subnet. It has a management, and with P-chain you can request information for those validators. In fact, this P-chain is focusing in know about what are the validators of a specific blockchain, and with this knowledge, this is other technology that we can see in the next slides. The other blockchain that is the most important for us, for developers in that case, is the C-chain. C-chain is literally a copy of Ethereum virtual machine for dApps, for smart contract and infrastructure. For the reason, if you are a developer and you want to deploy a smart contract and participate in this hackathon, I think that the most important for you could be the C-chain in the normal case. There are other things that you can consider in order to create your own subnet, but normally you can use the C-chain for your project and for your necessity. No, okay, I like it. I like it, the fast time to finality, the secure, the scalable, energy efficient, and lightweight. What I have to know in order to use the C-chain, because the C-chain is the blockchain that is deployed right now, yeah, and I can use in order to use this possibility and this advantage. And what I have to know about C-chain. C-chain is a form of the Ethereum virtual machine that enables the creation of Solidity smart contract. For the reason, if you are a developer for Ethereum, for Celo, for Binance Smart Chain, for Polygon, or anything that anyway that are using Ethereum virtual machine and Solidity, you can use the same language in order to program smart contracts in Avalanche ecosystem. For the reason, if you know Solidity, you can use Solidity here. Second, higher speed, higher throughput, lower fees, and shorter transactions confirmation times. Everything that we were seeing in this presentation, this slide, you can use and you can abstract this power if you are using C-chain. And other thing that is very important for developers is the time for the compatible with the full suite of Ethereum developer tools. If you know, for example, Remix, you know, Hard Hat, Truffle, Ganache, are you using Ethers, Web3.js, you can use those tools into C-chain in order to interact with the C-chain because it is compatible with the Ethereum developer tools. Every tool that you know in order to interact with C-chain could be used if you want to deploy and you want to use C-chain in order to deploy a smart contract in this network. For the reason you can use the same tools here with us. No, if our project doesn't have, if you think, okay, I would like to use this, I like the faster time to finality, secure, scalable, but I have a specifically condition that I can use the C chain because it has a specific particularity. I need to use other thing. You can use a subnet. I know why a subnet, or maybe how many subnet are using. Maybe you can think, okay, but a subnet maybe could be very expensive, maybe could be involved a knowledge that I don't have in right now. How many subnets are deployed right now? If we want to think how many subnets are deployed right now, we can looking for information in this web page, snowper.io slash subnets. This is an example about how many subnets we have right now in mainnet. Those are some examples. For example, if I press Avalanche primary network, we can see that we have C-chain, X-chain, and P-chain. The virtual machines are Ethereum virtual machine, AVN, and PVM. In the example, for example, the Exalot, we have one chain that comes with 10 validators. In the case of Avalanche primary network, we have more than 600 of validators. If we want to think about, for example, Fuji, okay, those are the subnets that are deployed in production. But what about Fuji? What about testnet? If we are talking about testnet, we have a lot of subnets. Those are a lot of projects that are deployed right now in the subnet. Those are different things that user has brought, but try to use it in the example or in the subnet, in the testnet in order to test their project and their ideas. And your project could be here if you like to use Avalanche in your project, and you can think about subnet, and you can consider about how I can use subnet. If you consider to use a subnet and you would like to deploy your subnet in Fuji, your project could be here. But when I can use a subnet, when is ideal to use a subnet? What I can get if I use a subnet, because I know that I can use C-chain. It's very simple because I have to connect my address, my wallet, in order to deploy a smart contract, and I can create a smart contract using Solidity, and I can deploy the smart contract. Very simple. But what I can get if I am using the subnet, I can get, for example, the independence. If we can think about subnet B could be a specifically subnet, a specifically process. Subnet AB could be another specifically process. And I can think, okay, subnet A and subnet B, I don't like to use my project. I don't like to deploy my smart contract into subnets. I need an independence space in order to deploy my smart contracts. I can create a specific subnet focus in my project. It could be the case of the video game because they have to spend a lot of traffic of information. They have to send a lot of transactions. For the reason they need a specific subnet focusing in their idea, in their project, in their NFT, in their traffic. Because it's like, I think, okay, I live in this build. I am living in a build, but I need to go to the supermarket. And maybe the normal way is to go to the supermarket if the supermarket of the highway is the way to send transaction and I am the transaction. I would like to move me from my house to the supermarket. I can think, okay, if the normal way are very, very busy, it's the rush hour every day, I can create a specific highway in order to move myself to this supermarket. If I am creating the build, if I am the owner of the build, I can think, okay, if I create a build, I have to create at the same time the highway because it's a build with 1,000 of apartments, 1,000 of people, and if we have 1,000 of people trying to move at the same time, they can generate a rush hour. For the reason we have to create a specific highway focus in this build. And in this example, it's the same. If I have a product that needs a lot of transaction, I can create at the beginning a specifically sonnet focus in this solution in order to have a more capacity independence of the other blockchains, of the other sonnets. Other thing that I can get is the customizability. In that case, if I have, for example, my project and I think, okay, I have to transact a specific information, and for the reason I need to modify specific low-level variables in the smart contract. Solidity is very high level for me, for my project. Solidity is very high level for my project. I have to create a specific sonnet that are using a WASM in this virtual machine. For the reason I can create a specific sonnet with WASM for virtual machine. I can create a specific architecture, a specific configuration. In the same example, for example, I can think that the best way to go to the supermarket could be using cars, but I can think, okay, maybe the better way to go to the supermarket could be to use boats or trains, and I can change the normal thing to move the information, the normal thing to go from the specifically start point to the destination point. I can change the way in the middle in order to have a specific throughput or anything specific for my project that I need. No, if we know that I can get independence, I can get customizability. What other thing I can get if I have to take the decision to deploy my project in a subnet instead of the C chain? What other thing I can get? Other decision that can change my idea or my mind in order to don't use this system is if I want to use a native gas token. For example, I can create a specifically system in what I have to, for example, I am a bank and I need specifically gas because the AVAX, I don't like the AVAX because AVAX is very fluctuant or Ether is very fluctuant or other blockchains or other tokens are very fluctuant. I can create my specific native token in order to pay the gas for my subnet. This is an example in what I can think about. Okay, I have to create a subnet instead of the chain. Other example, if I need a higher throughput. If I need a higher throughput, I have to think about, okay, I need a higher throughput. I need to transact a lot of transactions in a short period of time. I need to create more lines in the same highway. I had to use a highway with a short time to finality, but I want to create a specifically highway with a lot of lines. For example, a highway with 10 lines, with 12 lines. I have to create specifically for my project because I know that I have to use all the potential of this machine. In that case, I can create a host dedicated chain focused in my application. This is the idea, or this is a reason to use the subnet. Other is when I need a strict user access control. When I need a strict user access control, for example, if I am a bank or I am a specifically user for a specific project, or for example, for an institutional government project, and I need to have some different users that are passed for a KYC or ALN or a specifically process in what they validate their identities and they give me the no accessibility or the no relation with them in order to make sure that I can trust in them. In that case, I can create a specific subnet in what every user that can deploy a smart contract or every user that want to transact information in this smart contract has to be authorized. For the reason we can create a specific subnet with a precompile that require that only you authorized user may deploy contract or make transactions. We can create a specific subnet with those configurations. Other necessity is when we need a virtual machine customization, we can add a specifically precompile in order to modify the normal way or the normal things in the virtual machine in order to get our solution for our project. The idea is we can create a specifically blockchain focus in our project and we don't have to adapt our project to the blockchain. We can use every power or all the power that offer us Avalanche in order to create the most or the better blockchain for our project. No, okay, I had create my own blockchain because I need a specific configuration. But one of the things that we can think after creating a blockchain is, okay, I have my blockchain, but no, my blockchain is an island. Oh, my blockchain is an island. My blockchain is disconnected with the real world. What I can do? If we are using the Avalanche ecosystem, by default, we have in the C chain, and when we are deploying our subnet, we can choose to have the Avalanche warm messaging. This is a specifically precompiled that gives us the possibility to send message between different subnets. This is the precompile that gives us the possibility to send message to communicate between different subnets. For example, if I create my blockchain, my subnet, and this is my blockchain is focusing the institutional or the hospital and I need the information about this chain. For example, I create a subnet focusing in the hospital, and I need to pay a specific insure for users. The the liquidity normally is in C chain in the mainnet. For the reason, I need to connect the subnet that has information about the user with the C chain in order to give the instructions to give the money to the user. I don't have the money, I don't have the liquidity in my subnet focus in the hospital. The hospital could be a specifically private blockchain, a specifically private chain, but I can take advantage of the liquidity that is in C chain, and I can send a message in order to give this liquidity to the user in C chain, and I can send message data between through those blockchain using this precompile. This precompile, if we are deploying or we are creating smart contract using C chain or any blockchain that is compatible with Ethereum virtual machine, we have an abstraction of this precompile. The abstraction is named Teleporter. And I invite you to the workshop about Teleporter tomorrow with Megan. Also in this hackathon about Chainlink, and you can know more about this contract, because we can use our product, our specifically contract. I can connect this abstraction of sending message through different blockchain using Teleporter, using a smart contract. We don't have to configure it to set in nothing in the background. We have to use two smart contract or one smart contract. Our smart contract, and we have to extend the contract of Teleporter, and it's very simple. I invite you to see tomorrow. Other thing that I would like to show you is about what does business development do. We have different partnerships and ecosystem projects that are using right now this technology. Those are different examples that are using right now the Avalanche ecosystem. No, if you are thinking right now what project could be good for this hackathon, or what idea could be good for this event, I can recommend you different verticals. For example, one vertical could be DeFi and dApps. Those examples about this vertical could be Trader Joe. Trader Joe is a web page, it's a DeFi app. Other could be, for example, capital market, institutional capital markets, or different company. For example, JP Morgan and Citibank are banks that are using right now this technology because they need a specifically configuration to give access to specifically user that have passed by a process of KYC. For the reason, they need a strict system to validate information, and they need a strict control to what kind of user can send transaction, can interact with the smart contract, can deploy a smart contract, and for the reason they are using right now this technology. Other example could be enterprise, could be gaming, NFT, arts. If you want to create a project focused in NFT and arts, you can do it. We have different subnet or project deployed right now. Different exchanges and wallet. We have partnered with different exchanges, for example, Coinbase, Robinhood. Blizzard Fund is a venture capital that is focusing in investing in those type of projects. Right now, it has investment in more than 200 projects. No, this is an example of different subnets that are deployed right now in the Avalanche ecosystem. For example, Dexalot. Dexalot is a good example. Dexalot is a subnet in what you can give your assets in C chain, and you can get the equivalent in Dexalot, and you can transact those assets in Dexalot, paying a less gas than if you are using the C chain. You can pay a little fraction of the normal gas in a specific subnet, and you can create your subnet specifically for your project. This is an example. No, if you want to know more about this technology, about what you can do with this, you can take those course. This is the Avalanche Academy. If you don't know anything about programming, if you are curious with this thematic, with this topic, and you would like to know about, okay, what is Avalanche, what I can do with Avalanche and other things, and you can think more in the information about the consensus method, I invite you to take the course about Avalanche fundamentals. If you want to know more about, okay, I know about Avalanche fundamentals, I would like to create an architecture, create a subnet, you can take the course about subnet architecture, or you are an architecture and you like a lot the customization, and you think, okay, I want to create a specifically subnet because I have an idea and I want to create it. You can take the course about customizing the Ethereum virtual machine in order to have the minimal knowledge about how to create those precompiles in order to give advantage to this blockchain. If you want to do it, I invite you to scan next QR code. This is about Discord, Telegram, and Avalanche Academy. Feel free to ask any question that you want. If you have a specific question about a specific topic, you can ask about it, and we can solving this problem or solving this question. In a moment, connecting. Yeah. Yeah. For the reason, if you need anything about it, you can ask in those channels, and we can answer your question. Now, let's create communication channels between a smart contract using CCIP. Howard, we have questions or any question right now, or we are good?
No, we are good
We are
right
good.
now, Alejandro. Yeah. You can keep going.
Are we good? Okay, next. If we know about Avalanche ecosystem, we like to use it, we can think, okay, I like Avalanche ecosystem. One of the advantages that we can have or we can get if we are using Avalanche ecosystem or C chain is we have a short period of time to finality. With this in mind, we can think, okay, what if we can send a message between Avalanche and Ethereum? We can use, for example, C-Chain Fuji. Fuji is the testnet of Avalanche. We can send message from C-Chain and Avalanche to Sepolia in Ethereum. For do it, we can go to the documentation of Chainlink. We can looking for it in Google, say Chainlink CCIP. And when we are in Chainlink CCIP, we can go to the documentation, and here in the documentation, we have to think two different things. We know that we want to send message. Okay, we want to send message between two different subnets, two different blockchain, two different ecosystem. No, if I am in the Avalanche ecosystem, what thing I have to have in mind? If I want to send message, I have to have a Avalanche Fuji. If I want to deploy a smart contract, I have to have a Avalanche Fuji tokens. For this reason, I recommend you to go to this link faucet. This is a trick. This is a trick that because you can, okay, I have to go to a specifically faucet for Avalanche. I have to go for a specifically faucet for Ethereum. But if you are looking for links, you can have faucet for Avalanche or for Ethereum. In that case, I can choose this option. I can connect my GitHub, and I can request some different tokens for links and for Ether. At the same way, if I chain, for example, for Avalanche Fuji, I can get some testnet tokens for Avalanche Fuji and links. If I want to send a message from Avalanche Fuji to Ethereum, I have to deploy a smart contract in Avalanche Fuji. For the reason I have to have AVAX, and I have to deploy a smart contract in Ethereum, Sepolia. I have to have Sepolia Ethers. I have to have AVAX and Ether. An additional, if I want to send a message from Avalanche, I have to have links in Avalanche ecosystem, in Avalanche network, because I have to send those tokens to a smart contract in order to send the message. No, with this logic in our mind, okay, I have to send, the source blockchain is Avalanche Fuji. The destination blockchain is Ethereum. I have to send a message. I have to send a message. I have to deploy a smart contract. Deploy smart contract here, deploy smart contract here. Deploy smart contract in Avalanche, deploy smart contract in Ethereum. I have to have a faucet in both blockchains. Next, I have to have links in the source blockchain. In that case, it's in Avalanche. In my case, I have this token in my wallet, and I'm gonna continue with the documentation. Okay, this is an example. This is the testnet when you are looking for this information, you can go getting a start at testnet. I recommend you to have different tabs. In that case, this is the tab for the testnet in order to have the information needed to deploy a smart contract, and other tab could be the same but with the getting started. Why? Because in getting started we can find the step by step to send this message. For example, in that case we have the example. We want to deploy a smart contract and we have to example to send a message from Avalanche to Ethereum. The first step that they say is, okay, you have to open the code in Remix. In my case, this is the Remix. I have to create a new folder, in my case, for example, CCIP. And I know that I have to send a message between two different blockchains. For this one, I have to have two different contracts. First is the contract about sender. Other is the contract about receiver. Okay, I have to save those contracts in this folder. Yes. Yes. Yeah. I have two different smart contracts. And next, I have to go to the documentation, getting start, deploy the sender sol contract on Avalanche Fuji to see a detailed explanation of this contract with the code explanation section. This is the code explanation section. I can copy this smart contract, copy. I can open the remix. This is the sender.sol. Okay. This is a message about the code is from other place and I don't write this code. This is okay. This is the sender. This error is because I have other compiled version. This is the 0819 compile. The problem is solved. The other thing that I have to know is the receiver. Okay, let's go. The explanation. Here. I have the code. I compile the code and I have to deploy the sender contract. In that case, is on Avalanche Fuji. This example is tested in Avalanche Fuji because Avalanche Fuji is the blockchain with a shorter period of with the time to finality. For the reason we can make sure that the transaction is okay and the user or the send information between Avalanche to Ethereum send information in a less period of time. Now open MetaMask and select Avalanche Fuji network. Okay, this is my code. It is compiled. I can open the deploy tab. I have to use core. This is my wallet and core. I can deploy the smart contract, but before deploy the smart contract, it requires me for router and link. In the same documentation, in this documentation, I can looking for this. If I want to send a message from Avalanche to Ethereum, I can open this tab and it say me. This is the router, this is the chain selector, this is the link address. Oh, okay. What is the first? Router. Okay. Router is it? Router. I can copy. And I have to paste. Link. What is the link address? Link address is it. I can copy the link address and I can paste the link address. After it, I can deploy it. It say me that it is in Sepolia. I have to choose Avalanche Fuji. Avalanche chain. Custom. Yeah, this is the chain ID of Avalanche Fuji. I am located right now in Avalanche Fuji. I have to transact. I have to deploy this smart contract. It requires me for payment the gas. Okay, I approve the transaction. The transaction is sent. And now, while the transaction is approved, the transaction is practically automatically deployed. When the transaction is approved, I have to go to the documentation. Okay, the transaction, I have to choose this option. I have to send the router address, the link address. We can find it here. And next, click the transact. After it, you confirmation the transaction, the contract address appears in the deploy contract. Open MetaMask and set 0.1 link. In my personal opinion, right now, okay, no, in my personal opinion, right now, the cost of the gas is higher. For this reason, I will send more than 0.1. Copy. I open the core wallet, Chainlink. I will send to this smart contract. The smart contract has to has the links because the smart contract pay for person who send the message from Avalanche Fuji to Ethereum. In that case, I have to send to the smart contract. I can send in that case 0.5 because right now the price of the transaction is higher. Next, said no. Yeah, the transaction is sent. The transaction is sent. Okay, I have sent some links to this smart contract. Now, in this point, is the time of the receiver. I completely the step of the sender. The step of the sender, the smart contract in the Fuji is deployed and is ready to send the message. Now I have to deploy another smart contract in Ethereum Sepolia. Okay, this is the explanation of the receiver. I can go to the code. This is the code. I copy the code. I open Remix. I open receiver file, and I have to paste this code. This is the code. I can compile this smart contract. This smart contract is ready to deploy. I have to choose other blockchain. In that case, the blockchain is Ethereum Sepolia. In that case, with Ethereum Sepolia, I have to deploy this smart contract. But when I try to deploy the smart contract, it requires me for router. But what is the router? I have to open again this tab, and I have to go to looking for Sepolia. In that case, I have the tools for Fuji, and I have to open the tool for Sepolia. The question is, what is the router? This is the router for Sepolia. I have to copy this, and I have to paste it here. I have to transact. Okay, no, I have okay, no, it's in Sepolia, yeah. I was thinking that I have the address in in Fuji, but the address is in Sepolia. I can transact it. I can pay for the gas, and after it, the contract will be deployed in Sepolia. Yeah, the contract is deployed in Sepolia. This contract is deployed in Avalanche Fuji, and this contract is deployed in Sepolia. If I require for information about what is the last receiver message, the last receiver message is empty because I don't have to define or initialize this variable. For the reason, I have to send a message from Avalanche in order to get the message in Ethereum. I have to change the chain for Avalanche. And now we can follow the instructions. Okay, the instructions we were in what detail here. We deploy the smart contract, the receiver smart contract, we compile the message, we deploy the smart contract using the router address for Ethereum, and after it, we have to send the data. We have to send the message from the source blockchain. In that case, the source blockchain is Avalanche Fuji. We have to send a message. Okay, I have two smart contract. I have the smart contract sender deployed in Avalanche Fuji, and I have the receiver smart contract deployed in Ethereum. For the reason, I have to send the message. I open the tab for sender deployed in Fuji, and I open the function about send message, and it requires me for the destination chain selector. Everything is in the documentation. The documentation is also, you can find anything here. If I want to send a message, a destination chain selector, okay, I want to send message to Sepolia. Sepolia destination chain selector is here. I have to copy. I have to paste here. Receiver, what is the receiver? Okay, the receiver, this is the address, this is the smart contract. I have to copy the address, and I have to paste here the address. Next, what is the text? The text could be hello hackers. Hello hackers. And I can send the transaction using transact. It requires me to pay the gas to send the message. I approve the transaction, and the message is sending right now. Yeah, the message is sent it, but it's sent it in Avalanche ecosystem. I can looking for the transaction in the Chainlink ecosystem because we are sending the message from Avalanche. Right now, any user of any validator of Chainlink has to get the transaction, have to review the transaction, and have to send the transaction to Ethereum, and the transaction in Ethereum has to be processed in order to show me the new value. For this reason, we can see the transaction. In the documentation, it say, okay, where after you are sending the data, you can looking for the details here in CCIP Explorer. Okay, CCIP Explorer, I can looking for message ID, transaction hash, or address. In that case, I can see, okay, I have this contract, I can copy the address, and I can looking for the smart contract here. And it say me, okay, this is a transaction. You have sending a message from Avalanche. Avalanche is the source chain, and Ethereum Sepolia is the destination chain. This is the address from to the origin. This is the address of destination. This is the message that you are sending. Hello, hackers. And this is information about it. The price of the transaction was 0.3. At least I send 0.5 because if I would send 0.1 or 0.2, it could be it doesn't work. I have to wait until this transaction finish and change from commit to complete. When the transaction finish, it shows me that it is complete and I can require for the value in the destination blockchain. In that case, in Ethereum Sepolia. It can spend some seconds. It depends of the Ethereum Sepolia also in order to save the transaction, in order to save the information. It is committed right now. And yeah, this is the process in what we can do it. While it is processing the transaction, I can change the wallet. Okay, I was in Avalanche. I can change for Ethereum Sepolia, and I can looking for receiver CCIP transaction. What was the transaction? CCIP Explorer is commit. Okay, it's commit. Is not yet available. And yeah, this is the process. We can talk about this. We can choose the testnet that we can use. In that case, we can send message from Avalanche to Ethereum, to Binance, to Arbitrum, to Base, to Optimism, to Polygon. We can choose any wallet or any chain that we need to send message between different blockchain using CCIP. This is the way. The way is very simple. We have to follow the documentation. We have to deploy a smart contract in the source blockchain. We have to deploy a smart contract in destination blockchain, and we have to give some links to the smart contract in the source blockchain in order to pay for the gas, or in that case is the gas for validator of Chainlink in order to send the message. This time could spend some minutes, and yeah, while it finished, anyone has any question or anything? Anyone has any question or anything to ask at this moment, or everything is okay?
So we have one question here, which is it possible to integrate with Avalanche subnet that is a private chain?
Okay, yeah, in Avalanche ecosystem, we can create a private chain. If you are thinking about use CCIP in a private chain, the thing is, CCIP is a product from Chainlink. CCIP or Chainlink have to decide what blockchain they can implement this product. In that case, CCIP. The thing that you can use or you can do in that case is you can create your own subnet. You can create your own private subnet, your own private configuration using the Avalanche CLI. After creating it, you can use Teleporter in order to get message from C-Chain. In C-Chain is available CCIP. For the reason you can get information from other blockchain different to Avalanche using CCIP in C-Chain, and you can get this message in your own private subnet using Teleporter. It could be a solution in order to get this solution in your subnet, in your private subnet.
Awesome, thanks. That was the only question so far.
No more question. Okay.
Not at the moment. So if you have any questions, feel free to drop them in the chat and we'll go through it.
Okay, it could spend some minutes. I would like to show you the answer, but it can spend some minutes. But yeah, you can see here the message that you can see. And those are different things that are sending at the same time in the transaction. My recommendation, if you want to use CCIP in order to send message, is you have to follow the documentation. Just If you want to use any documentation, you have to looking for docs and the name of the documentation, in that case, Chainlink CCIP, and you have to follow it step by step. And in that case, that it say that you have to send 0.1, you have to send 0.5 or more than 0.5 because right now the price of the gas is highest. In that case, is required for me 0.3, and I recommend you to send more than 0.1. Yeah. If we don't have more question, thank you for your time. Thank you for this space, and I hope you can give excellent projects. And if you need any question, you can ask for the channel that we have in Telegram.
Awesome.
Okay.
Thank you so much.
Okay.
Thank you so much, Alejandro. Yeah, there's no questions so far in the chat. So really appreciate your time here and sharing all your knowledge about Avalanche to our hackers. And yeah, with that, we'll end it here. And again, as Alejandro said, if you have any questions on Avalanche, just feel free to reach them via their Telegram chat for our hackathon, and the team will definitely help you there. And yeah, so thanks everyone. Have a great rest of the day, and we'll see you at the next workshop. Bye everyone.
Thanks. Bye bye.